Hello and welcome to another video from PlodWare. In this video we're going to do a little demonstration of using the Adafruit MCP2221A breakout board for digital input and output and analog input and output, and it will be driven from a Windows PC running a freeware interpreter, the pwScripter, from my website PlodWare. There is a disclaimer, as always. This video is provided for informational, educational use only and is neither sponsored nor solicited. Where reference is made to any third-party organization, source or documentation, then that reference was made under the assumption of fair use. Other than being a user of some products referenced in this video, Adafruit, Microchip Technology Inc, and Microsoft Corporation, I have no connection with any of these companies, their employees, representatives, or subsidiaries. If you want to reproduce this demo, you need some software resources, specifically Microsoft Windows 7, 10, or 11 platform running on a desktop or laptop, the DLL MCP2221-DLL_UM_X64 from Microchip Technology Inc, the freeware pwScripter interpreter from my website, a script NS MCP2221A IO ADC DAC from my website. Details about locating and installing the DLL pwScripter and its script are given towards the end of this video. Right, I've already downloaded the pwScripter executable, and I've placed into it in this area here the script. We're going to simply run it by clicking on the executable or execute lines button here. But before we do that, we need to have a look at the hardware. This is the hardware that we're going to use in the demo. I'll quickly explain what the various components are used for. We're going to have digital input driven from this area. That's actually a potentiometer or variable resistance, and we'll just turn it up or down to create a voltage. If the voltage is below the threshold for a logic 1, then it'll be treated as a 0 input. If the voltage is above the reference for a logic 1, then it'll be treated as a 1. The demo is going to read in this value and spit it back out to the digital output. And then we're going to do something similar with the analog input. We're going to have this here, the potentiometer, which we'll turn up and down, and its voltage will then be measured, and it'll be echoed via the output, analog output, to the voltmeter. Nothing particularly clever. What we're going to have to do first is run the script to start up the demo, and when it does, the demo will go into a loop for about 40 seconds, and in those 40 seconds it'll read the inputs and echo them to the outputs. And when it's about finished with the script, the LED will flash for a few seconds, for about 3 seconds, to show us that it's about to finish. So I'm now going to run the script by pressing on the execute lines, but first let's give the board some power. Okay, it looks like the default outputs are automatically level logic 1 or maximum. You'll notice how the voltmeter maximum seems to be 3.28. It's about 3.3 volts. We'll discuss that again later. It cannot, in this configuration, provide more than this voltage. Let's now start the demo by clicking on the execute lines, and here we go. reads the inputs, reads the outputs. Let's play first with the digital input. Turn it back down. Whoops, fingers out the way. Turn it down, there it goes. Play around with the analog digital. And back down again. Nothing fancy. Now it's flashing to say the demo, the loop is almost finished. That's it. That's the demo. From here on, it's just looking at the script that we use and information about how to get the software modules or software components if you want them, and a little bit about PlodWare and myself. I did say that there was a slight issue on what voltage this board runs at. I spent a long time expecting the digital output to go up to about 5 volts and that it would, the potentiometer providing the analog input could also give up to about 5 volts. No, the board as it is pre-programmed so that the internal working voltage, the VDD, is 3.3 volts. I thought it was 5. It wasn't. Eventually I found out, it took a few days, I found out on a Adafruit forum that quite simply turn the board over and you'll see that there's a little jumper there which makes VDD 3.3 volts. Invariably when I have these understanding problems, I know at the end it's probably just me being stupid, and in this case I was right. It was my fault. Right, let's have a look at the script, the pwScripter script used for this demo. Now it's worth noting that the script comes in 2 parts, a generic part which will be applicable to basically any of the Adafruit MCP2221A demos that I'm doing, and a smaller, much smaller part, the specific part, which is actually focusing on driving the GPIO demo. Let's have a quick look at the script. The total script is almost 700 lines, over 300 or almost 300 of them are comments. The script is based on the DLL user guide that I was able to find. I found this inside a zip file from Microchip Technology Inc. I've copied quite a bit of comments out of it and embedded some of the comments into this script file to save you referencing it, but I strongly recommend that you get a copy of the DLL user guide if you decide to do any of your own programming with this. The DLL exposes around 60 functions. We don't need all of them. We'll need about 25, 26 of them. So to make our life easier, we're going to create wrappers around those. And we'll do that using this function, MCP initialize DLL. It'll open the DLL. And if the open is successful, it'll get a handle. And then using that handle, it'll create a wrapper around one of the functions. I'll use as an example this one. If you want to, this one. If you want to set what function a general purpose pin has, then you've got to provide what we call this function, the set GPIO settings. It takes a handle of the target chip or device. It'll need a flag to say, are we going to set the working values or the stored values? And we'll have 3 arrays. One array will say whether the pin is a input-output pin or an ADC or a DAC pin, whatever. a second array to say if it's a GPIO pin, is it an input or an output pin? And if it's an input or output pin, the third array will tell us what the default value is. And all of that I will, in this case, pack into this wrapper. The general rule is if if a function name starts with an underscore, then it's a direct reference to the DLL. As I say, this is the biggest function by far because of the comments. It takes us up to 300 lines, so that's almost half of the script is just in this to get us to here. Once we've got these various wrappers, we can put them inside our own functions to make life easier. For example, if you want to find something out about the DLL itself, you can call MCP display DLL info. Let's actually do that. So we'll take a copy of that. We'll call up good old pwScripter. We can type in display info. I'll clear this area so that when we write to it, we'll see that it's new. Execute it, make it a bit bigger so we can read it. And it says the factory serial number is 2.2b and there's one connected device. Okay. If we go back to the script, we'll find somewhere there is a get device info. So let's run that. Go back to pwScripter, put in the command. It wants the identity of the target chip, which in our case defaults to MCP handle. I'll clear the display area and then execute that line. And there it gives us some information about the chip. Right, there, as I say, there's a few functions, about 25, 26 that we will reference. This includes functions that we don't need in this demo, so it'll include SMB or the SM bus interface and some I2C routines. And there'll be some routines where, as in this case, it'll read the general purpose input-output bits and then display them for us and say, oh, this is an on or this is an off. Right, let's run this MCP read GPO IO bits. We'll go back to PlodWare. The demo hardware is still connected. We're going to run the read command. And here's the current output. It says the first two pins are GP, IO. The second and third pins are not. So this is giving us a brief overview of all four. And it says the inputs seem to be a 0. I'm going to turn up that potentiometer, run it again, and this time it says the first pin is on a logic 1. All right, let's go back to the script. There's a lot of generic stuff in the script. It goes on and on. And around here, 594 lines. The generic part is finished. Now, about the demo part, the part of the script that's specific to this demo. We're going to define a couple of functions. For example, this one, which will configure the general purpose I/O pins, or general purpose pins, to be, in this particular case, an digital input, digital output, analog input, analog output. As I've mentioned earlier, to do that we need 3 arrays, an array to define the pin function, the direction, and the pin values. 0 here means it's an I/O pin. 2 means it's an analog digital conversion pin, and 3 is it's a digital analog conversion. So it's a output pin. The actual demo itself is just a loop. It's going to go through this. Actually, I think we'll run it 1,000 times. It'll sleep for a short time. Then it's going to read the analog digital conversion values. There's only one, it doesn't matter. It's going to read them, get the first one, and send it back out to the digital analog conversion. So we'll send an analog input to an analog output. And we'll do something similar with the general purpose I/O pins. We'll read the state of them, specifically pin 0, and we'll echo it to the output pin. And then when we finish, we'll go into a little loop to flash the LED to show that the demo is finishing. So that's the support functions. When we actually run the code, we initialize the DLL, display a bit of information, open the MCP chip or device. In this case, we open the first device we can find in the enumerator. That's 0. Display some information about it. Configure that chip to have the general purpose pins as we want them. Then we're going to have to initialize all the inputs and outputs pins to be 0, and we'll initialize the digital output to be 0. Now we hit this gotcha that I had with 3 volts and 5 volts. There is what they call a reference voltage for the analog digital conversion. It says if a voltage is above this reference, then it's full scale, it's the limit, we can't go any higher. And I thought that was set to 5 volts. It wasn't. It was set to 3.3 or 3 volts roughly. And in the same way, the output of the digital analog conversion, 10 bits, when all the bits are set, I thought, oh, we're going to get 5 volts, and we only got 3.3 or thereabouts. And again, you have to set the DAC reference voltage. These set it to the default values. There will be a function earlier on which will display or convert that into the appropriate value. And then run the demo. The demo is set up to loop 1,000 times and to wait a nominal period of 1. Ideally that would be in milliseconds, but running on a Windows system, you can't really stop a function, or a thread for a millisecond. You can keep it busy for a millisecond, so it can't do anything else. But if you actually put it to sleep, because of the way the thread or process handling works, I think the minimum time you can do this for is somewhere around 50-60 milliseconds. I don't really know, but what I do know is that I run this with 1,000 loops and that's set to 1. It takes around 40 seconds. If I put this to 0, then it runs for about 23-25 seconds on my system. Right, that's enough. If you want to get a copy of the MCP2221A, the DLL, or the pwScripter and its script, or know a bit about RipeTech PlodWare, then stay with me. If not, thank you for attending. The MCP2221 DLL that you're going to need is not from me, it's from Microchip. Specifically, you'll have to go to their website. Here's the link, microchip.com, and look for the MCP2221A. When I eventually found it, there was a zip file. It was labeled MCP2221 DLL v2.2.1. I downloaded it, unpacked it, and this is what I found at the top level. There's a folder called Unmanage, which we'll have to go into, and very, very useful if you want to do any work with this. There's a copy of the DLL user guide. If you go into the unmanaged folder, you'll find there the DLL that we need, the DLL _UM for unmanaged _x64. That's because pwScripter is a 64-bit unmanaged application, and the DLL has to recognize that. So I simply took a copy of this DLL and dumped it into my Windows System 32 folder, though I think technically it's enough to simply copy the DLL into the location, the same folder as where you're going to install pwScripter. Right, if you want a copy of pwScripter and demo scripts, stay with me. First of all, a disclaimer. You can take a copy of the RipeTech and PlodWare applications, scripts, documents, anything you can find. Use it to your heart's content, but please understand you use it at your own risk. There may be changes or updates which might render a script unusable. So far I've managed to keep the compatibility to a very high level. And by all means, if you want, use this, distribute it. The only thing is, don't try to imply that there's any more guarantee of functionality than stated here in this disclaimer. You can get a copy of the pwScripter from my website. It's ripetech.com. And there is a folder underneath that, downloads and script files. And there you'll find a link to a pwScripter zip file. It's one zip file with only one file inside it, the executable. Download it, unpack it, and place it wherever you want it. I put the executable often on the desktop. And then double click on it and it should run, and you should get this sort of appearance. If you get this blue screen, don't panic. Simply double right click on the executable, the entry in the file system to get the properties pop up. Go to the general register and you should find an unblock option. Tick it so it's marked as unblocked, apply and exit. Then simply run the script, the executable, and it should pop up like this. The demo scripts are also on my website. Again, under downloads and script files, somewhere here there will be a range of possible scripts. Look for the one you're after. It's a simple text file. Either click on it to open it and take a copy, cut and paste, or download it. But the goal is to get a copy of the text into this edit panel of pwScripter. Once you've done that, usually you just have to click on the executable, execute lines command here, and whatever is in this edit panel will be executed. Right, I've talked about RipeTech and PlodWare. There is a slight difference. A little bit of history. I started in around 72, 74 at school, programming in a language called Cecil, which you've probably never heard of, and of course BASIC. Unfortunately, the BASIC was done on a snail mail basis where we had to post it off to the local council offices who type it in for us, run it, and then send us back a sheet saying error, inline, whatever. However, it was a start. From about 76 at university, for a few years I mucked around with algol W. I mucked around with alcohol as well. And then from about 79 onwards, I was seriously involved in Intel 8085 assembler, Intel 8080, 186, 286, 386, whatever assemblers. Intel's own language, I think, if I understand correctly, called PLM, a bit of Pascal and a bit of CCITT Chill, which is a telecommunications language. Around about 1988, I had a Atari ST, a Motorola 68000 based machine, and I discovered a Forth-like language. I couldn't get it to work properly, and I was so angry at my own incapability that I bought a book on Forth, found out how it functioned, and started writing my own versions. Of course, the first thing I wrote was a version for the Atari in Motorola assembler, followed on by VAX, VAX 1170, written in Pascal. No, it was only CLI, there was no graphics mode. Then I played around with a SunSpark workstation in assembler. That is a mind-blowing activity. And using a thing called Motive, which was a graphical interface. That was fun, but different, because the assembler is so unusual. At least it was to me. And then I started with Windows 98 using C and a Motive lookalike called LessTIF. And then I decided, what the hell, I'll try to do it in low-level Windows. Again at C, so I started doing message handling to manage the GUIs, define my own Windows structures, whatever, added in DLL access. Then I added in embedded the SQLite engine, a brilliant thing, I think. I'm very grateful to the SQLite people. All that was basically to get a Forth environment, but then I decided that BASIC, as being the language I started with, I should have another go at. So I worked on a script to convert the Forth language to run a script so that when it ran, I'd have a BASIC-like interpreter, but modern, not with go-tos and line numbers, but a fairly sophisticated BASIC-like interpreter. And that ended up with over 50,000 lines of Forth code. So that's me. All that's left now is to say thank you.